dear friends, thank you for your comments that help me and the channel grow. We have plans for your suggestions, and if they are relevant to the topic, we'll briefly explain them. In the headphones video series, at the first we explore a general overview, then PCB, lithium polymer battery, and the speaker drivers. Now it's time for a summary. In this video, we'll compare earphones, headphones, and headsets, discuss their feature, Wi-Fi integration, health risk of improper use, and key mentions types. So stay with me. What's the difference between earphones, headphones, and headsets? All three serve one main function: converting electrical signals from your phone or computer into sound using drivers, miniature speakers. Let's look at the differences. At the first, what is the headphone? A headphone consists of two large electrostatic drivers that sit on or around the ears. They usually provide through sound, left and right channels, and have an acoustic chamber that makes the sound clearer and deeper. They are used for highly quality music listening, gaming, mixing, or podcast recording. Now it's time for type of headphones. What type of headphone we have? Okay, I hope you see it. Yes, by physical structure, we have over air surrounds the entire ear like a soft cushion, deeper bass, and better isolation, ideal for home listening. Then we have on air, lighter and more compact but may leak sound. Then we have open back. The back is open for a natural sound, but everyone around can hear it. And closed back, seal back, great for noisy environments like subways. By driver type, we have the first dynamic driver, affordable, simple, with strong basses, common in regular headphones. Planar magnetic driver, thin diaphragm between flat magnets, very accurate sound for professionals usage. And electrostatic driver, extremely high sound quality but needs a spatial amplifier. Then we have a hybrid driver, combines multiple drivers for full range sound. By connectivity, we have at the first wired, stable connection, no delay, high fidelity. Wireless Bluetooth radio frequency, comfortable and cable-free, but has charging limits and possible delay. And the last we have ANC, active noise cancelling. These headphones cancel surrounding noise by using inverse phase circuitry. Now it's time for internal circuits. Yes. At the first, you can see here we have an internal circuit. Amplifier, boosts signal in stereo or wireless models. Then we have a Bluetooth chip, acts like a brain, handling ID codecs, for example aptX or AAC. Then we have a battery and charging circuit, lithium polymer battery with a PCM protection circuit model. Then we have a ANC circuitry. Microphone captures ambient noise and the circuit cancels it using inverse phase signals. Then we have a driver. Driver usually dynamic with a copper coil and neodymium magnet for strong basses. If we want to look at the acoustic design, we have two acoustic design. At the first, closed back. What is the closed back? Stronger bass but a bit boxed in. And we have open back, and in open back, natural and spacious, like being at a concert. Sound architecture. Some models include a waveguide that directs sound's battery to your ears. Now it's time for headset. What is a headset? Yes, we have again this here. A headset is essentially a headphone with a microphone letting you both hear and speak. It's perfect for gamers, podcasters, or online meetings. Now it's time for types of headsets. By physical design, we have three headsets. And the first over-ear, best for pro gaming or podcasting, just make sure it's not too heavy. Then we have on-ear, lighter, ideal for everyday calls. And last one is mono headset, single ear, designed for drivers or call centers. By microphone, boom microphone, position near your mouth, perfect for noisy places. Inline microphone, but is dead. Built into the cable, simpler but lower quality. And noise cancelling microphone. Filters out background noise for clean voice input. So let me show to you how this microphone works. This is a headset, okay? When we say boom microphone, I mean microphone is here and you can speak from here like that, okay? I hope you can see it. And when we say inline microphone, I mean microphone is over the cable, like here, okay? You speak from here. Yes. Now it's time for connection. In connection, we have three models. 3.5mm TRRS, ID and microphone on one jack. USB digital has a built-in sound card, higher quality, and Bluetooth wireless and convenient. So it's time for internal circuitry. Okay, I can show you right here and right here. Okay, like headphones, as you can see, I write headphone here, but includes a microphone, typically electrode or MEMS, with a preamp and ADC analog to digital converter. If it has USB models, include a DAC plus ADS chip to control both ID and microphone. Microphones are often cardioid to capture only your voice and reject ambient noise. Acoustic design usually close back to prevent sound interference with the microphone. They are tuned via software, for example, equalizer for gaming or speech clarity. Microphones include pressure ports to adjust frequency response. So now it's time for earphones and headphones. At the first, I will show you them. Yes, as you can see here. Yes, you can see it now. Earphones are compact and lightweight audio devices. They either rest on the outer ear, like classic earbuds, or go deep into the ear canal, like IEMS in ear monitors. The nozzle is a small tube that directs sound straight into your ear. For example, Sony WF-1000XM5 use a tone nozzle and ANC active noise cancelling to eliminate ambient noise. Now it's time for a type of earphones. Yes, wait a minute, I can show you. Yes, we have it here. At the first, by position. Earbuds sit on the outer ear. They are cheap and simple but have a weak noise isolation. IEM in ear monitors fit inside the ear canal. They offer excellent isolation and are often used by musicians and professionals. By driver configuration. By driver configuration, we have signal dynamic driver, as you can see here. Simple, affordable, and offers good bass. Common basic earphones. Then we have a dual triple driver. Dual triple driver, a combination of dynamic and balanced armature drivers for more accurate sound. And last one is balanced armature, very small and precise, commonly used in professional IEMs. By connection type, we have wired connects via 3.5 mm jack or USB-C, offers stable and consistent sound quality. Then we have wireless TWS through wireless straw, two separate buds with internal batteries. ANC enabled TWS, this actively cancels environmental noise using digital circuitry. Now it's time for look at the internal circuitry. But we have two internal circuitry, one for wireless and one for TWS. At the wired earphones, we have a simple design. At the first, we have a driver, then we have a resistor, and then we have a microphone, if it has it. And in TWS, we have a MCU, microcontroller unit, acts as the brain, managing Bluetooth, touch control, and signal processing. AMP IC amplifies ID signals. MEMS microphone, teeny microphone part with a digital noise cancellation circuit. And lithium polymer battery plus PCM, a small lithium polymer battery with protection circuit. Acoustic design. IEMs feature a nozzle sound tube that directs sound straight into the air. 10 soundboard. The nozzle is acoustically optimized to balance different frequencies, and vent tuning, tiny air vents are added to improve bass response and pressure balance. So now that we've seen the difference between headphones, headsets, and earphones, you might wonder, wait a second, my headphones have a microphone? My earphones do. So aren't they all headsets? Well, not quite. Let's break it down scientifically. Headphones are mainly designed for high quality audio playback, for example, music or gaming. If they include a microphone like the Sony WH-1000XM5, it's usually for basic calls or voice commands, not professional recording. A headset is made specifically for two-way communication, often with stronger microphones like boom or cardioid that cancel background noise efficiently, perfect for gaming headsets like Logitech's. And earphones, being smaller and more portable, often include simpler microphones, MEMS or inline, and suitable for everyday calls but not ideal for podcast or pro-level gaming. For example, I had a Bluetooth headphone with a built-in microphone, but since its primary focus was on adequately, I called it a headphone, not a headset. Now you tell me, does your headphone have a microphone? Is voice capability important to you? And now we came to the AI in headphones, a really good story series. Okay, AI acts like a smart brain inside modern headphones. Using machine learning algorithms and DCP digital signal processing, it analyzes incoming audio and ambient noise. The microphones pick up noise like traffic and AI generates an inverse waveform to cancel it out. For example, Google Pixel Buds Pro use AI to filter ambient noise. So if you are sitting in a cafe, you only hear your music, not the chatter around you. Advanced AI capabilities, as you can see here. At the first, we have adaptive ANC, noise cancelling. Sensors and microphones detect environmental changes. For example, airplane noise, and AI dynamically cancels it. For example, Bose Quiet Comfort Ultra uses adaptive ANC to eliminate engaged sounds while keeping human voices audible. And real-time translation. What is that? The microphones captures your voice, AI converts it to text, translates it, then plays it back as speech. Requires fast processing. For example, Google Pixel Buds support this feature. And battery optimization. What is that? AI learns your usage habits and manages energy accordingly. For instance, in silent mode, it reduces power consumption. For example, Jabber Elite 10 adjusts power based on usage patterns. And we have the feature of headphone right here, as you can see. AR and VR headsets. Headphones of the future will merge with virtual reality (VR) and augmented reality (AR. VR creates a 3D world you experience through a headset, and AR overlays digital information on the real world. For example, displaying text on the glasses. Combined with spatial audio and motion sensors, they can simulate the sensation of being at a live concert. And the next one is biosensors. Health monitoring. Today's headphones are equipped with optical sensors that can monitor heart rate, blood oxygen, and even stress levels, transmitting data via Bluetooth to mobile app. The next one is advanced connectivity and battery. Bluetooth LEAD offers improved quality using the LC3 codecs with lower power consumption. And fast charging. For example, 5-minute charge can provide up to 1 hour of playback. And wireless charging under development for seamless power delivery. And the last one is a spatial audio. Using head-related transfer function, multiple drivers and powerful DCP headphones can simulate depth and direction of real-world sound. Imagine a day when your headphones read your thoughts and play your favorite songs. Okay, Wi-Fi in wireless headphones. I hope you can see it. Yes. Wi-Fi in wireless headphones. What is that? Wi-Fi is a wireless technology that uses 2.4 GHz or 5 GHz radio waves to transmit data. Instead of connecting directly via Bluetooth, headphones connect to Wi-Fi network, for example, your home router. How it works? At the first, it connects to Wi-Fi. Configure it internally or through an app similar to pairing your phone. And the second one is ID transmission. ID is sent as a digital data over the network. And the last one is playback. The headphones decode and output sound in their drivers. Why Wi-Fi? Higher ID fidelity than Bluetooth. Greater range covering the entire home. For example, Sonos Ace connects via Wi-Fi to your soundbar, delivering Dolby Atmos ID like a cinema headset. Okay, and some gaming headsets use similar 2.4 GHz tech to achieve ultra-low latency. Risks of improper use. Physical risk. I hope you can see it. Yes. What are they? Okay, it has a two parts: physical risks and technical risks. At the first, we have a physical risk and loud volume. According to WHO, exposure above 85 decibel can cause hearing damage. And next one is air infections. Dirty earphones or prolonged wear may irritate the air canal. And the last one is physical strain. Heavy headsets can cause neck or shoulder pain. Technical risks, what are they? At the first, we have non-original chargers, can damage the battery or cause fire hazards. The next one is cheap transmitters, risk of short circuits and device failure. And the last one is Bluetooth hacking. Low-cost earphones may have poor security. Imagine someone interrupting your music mid-song. Okay, and the next one is technical practical maintenance types. At the first, we have cleaning. Regularly clean silicone air types and airboat surfaces. The next one is proper charging. Use certified chargers and limit charging to 80-90% to prolong battery life. And the last one is suitable storage. Keep headphones away from humidity and dust. And don't toss them in the washing machine with your clothes. This concludes our headphone series. I hope you've gained a deep understanding of the headphone world. Now it's your turn. In the comments, tell me, do you prefer earphones, headphones, or headsets? Have you had any fun or disastrous experience with your ID gear? Got any ideas for the next video series? Thank you for being with me. Until the next video, take care of your ears and your eye devices. Bye bye!